Question number 8. Neha claimed that there does not exist any irrational number between 1 and 2. Raunak claimed that root 2 lies between 1 and 2 and root 2 is an irrational number. Who do you think is correct? Justify by proving either root 2 as an irrational number or otherwise. So first we have to prove that root 2 lies between 1 and 2. Next we have to prove that root 2 is an irrational number. Take 1 square is equal to 1 and root 2 all square is equal to 2. But 2 square is equal to 4. That is root 4 is 2. And here we can write root of 1 is equal to 1. We can see that for the squares 1 squared is equal to 1 and 2 squared is equal to 4. So 1 square and 2 square, 1 square is equal to 1 and 2 square is equal to 4, and root 2 all square is equal to 2, which is 1 less than 2 less than 4. So we can write 1 square which is less than root 2 square which is less than 2 square, which implies 1 less than root 2 less than 2. So root 2 is lies between 1 and 2. First statement is correct. Root 2 lies between 1 and 2. Next we have to prove that root 2 is an irrational number that we have done before in the chapter. Let assume that the contrary root 2 is rational. Then we can write root 2 as p by q form. Let it as a by b, where a and b are integers and b not equal to 0. So a by b can be written in the form r by s, where r and s are coprimes. Therefore, root 2 is equal to r by s, where r and s are coprimes. S not equal to 0. Squaring both sides, we get root 2 square is equal to r square by s square. That is 2 is equal to r square by s square. Then we can write 2 into s square equal to r square, which implies 2 divides r square, which implies 2 divides r. We can put equation number 1. 2 divides r implies 2, r can be written as 2 into k, where k is an integer. That is r 2 is dividing r, so r can be written as the product of 2 and an integer. That is let us take r is equal to 2 into k. Put the value in, let's take it as statement a. So put r is equal to 2k in a, we get 2s square is equal to r is 2k, that is 2k square. So we get 2s square is equal to 4k square. 2 can be cancelled. So s squared equal to 2 into k square. which implies 2 divides s square. That is, s square is the product of 2 and k square. So 2 is dividing s square, which implies 2 divides s. So we get two results. 2 divides s and 2 divides r, but r and s are coprimes. 2 cannot divides r and s. So this contradict that r and s are coprimes. Therefore, our original assumption is false. Therefore, root 2 is an irrational number. Question number 9. The HCF of 2 raised to 3 and 3 raised to 2 is option 1 2 raised to 0 into 3 raised to 0. Option B 2 raised to 1 and 3 raised to 1. Option C 2 raised to 3, 3 raised to 2. Option D 2 raised to 2, 3 raised to 3. HCF of 2 raised to 3 and 3 raised to 2. 2 raised to 3 can be written as 2 raised to 3 multiplied by, there is no factor of 3, so 3 raised to 0 is 1, so we can write 3 raised to 2 raised to 3 into 3 raised to 0. In 3 raised to 2 there is no factor of 2, so we can write 2 raised to 0. Since 3 raised to 0 is 1 and 2 raised to 0 is 1, we can write its powers of 0. So HCF is the common factors in both. Let's take 2. 2 raised to 0 is common, since in 3 raised to 2 there is no factors of 2. So we can write there is no common factors in 2 raised to 3 and 3 raised to 2. So 1 is the common factor. We can write 1 as 1 into 1. 1 can be written as 2 raised to 0 and 3 raised to 0. So the option A is correct. Question number 10. The LCM of two consecutive natural numbers p and p plus 1 is option A p, option B p square plus p, option C 1, option D 2p plus 1. We have given two consecutive natural numbers. Consecutive natural numbers is always coprimes. That is, let us take two consecutive numbers 2 and 3. They are coprimes. 5 and 6, they are coprimes. There is no common factor in both two numbers. So we can say that consecutive natural numbers always coprimes. Therefore, we have HCF is 1. Here we have the numbers p and p plus 1. So HCF of p and p plus 1 is always 1. Then we can say that HCF of p plus 1 into LCM of p and p plus 1 is equal to the product of the numbers p and product of the numbers p into p plus 1. So LCM of p and p plus 1 is equal to the product p into p plus 1 divided by HCF of p and p plus 1, that is equal to p into p plus 1, and HCF is always 1, so we get p into p plus 1. Solving this, we get p square plus p. So LCM is p square plus p. That is option B is correct. Question number 11. Assertion A. Root 3 plus 1 all square is a rational number. Reason R. Root 3 all square is equal to 3 is a rational number. Option A. Both assertion A and reason R are true, and reason R is the correct explanation of assertion A. Option B. Both assertion A and reason R are true, but reason R is not the correct explanation of assertion A. C. Assertion A is true, but reason R is false. D. Assertion A is false, but reason R is true. So first we have to check both assertion A and reason R. Reason R is true since root 3 all square 3 is root 3 all square is always 3 and is a rational number. So the reason R is true. We have to check whether assertion A is true or false. So root 3 plus 1 all square is equal to, we can express the expanded form. We know a plus b all square is equal to a square plus 2ab plus b square. Here a is root 3. So root 3 square plus 2 into AB. AB means root 3 into 1 plus B square, which is 1 square. So the answer is root 3 square is 3 plus 2 into root 3 into 1, that is 2 root 3 plus 1 square is 1. So we can simplify 3 plus 1 4, 4 plus 2 root 3. Here 2 root 3 is an irrational number. Therefore, addition of irrational and a rational number will get an irrational number. Therefore, 4 plus 2 root 3 is irrational. Therefore, we can conclude that root 3 plus 1 all square is an irrational number. So the assertion A is false. So the correct option is assertion A is false, but reason R is true. Question number 12. Prove that root 5 is an irrational number. 3-mark question. Let us assume root 5 is rational. Therefore, root 5 can be written as in the form of R by S, where R and S are coprimes. S not equal to 0. Then we can write root 5 into S equal to R. Squaring, we get 5 into S square equal to R square, which implies 5 divides R square, that is 5 divides R. So take it as equation of result 1, and this A 5 divides R implies r is equal to multiplication of 5 and a constant or a number. Take it as p. Then put r equal to 5p in 5s square equal to r square, that is a. We get 5 into s square is equal to, instead of r we can write 5p square. So we get 5 into s square is equal to 5 square into p square. Crossing 5's we get s square, cancel 5's we get s square equal to 5 into p square, which implies 5 divides s square, that implies 5 divides s, that is the result of 2. So we get 5 divides r and 5 divides s. So from 1 and 2 we can say that 5 divides both r and s. But r and s are coprimes. This contradicts our assumption that root 5 is rational. Therefore, we can conclude root 5 is irrational. Question number 13. If HCF of 850 and 325 is 25, then LCM of 850 and 325 is option A 442, option B 11,050, option C 8,450, D 2,210. We know HCF of AB into LCM of AB equal to A into B. HCF of the number 850 and 325 is given as 25. Therefore, 25 into LCM of 850, 325 is equal to 850 multiplied by 325. So LCM is equal to 850 multiplied by 325 all divided by 25. Here 25 can be cancelled here. In the numerator we have 13, so we can write 850 into 13, that is equal to, so the answer is B 11,000